Hello students, this video is the continuation of fundamental concept on nucleophilic substitution reaction. In this video, I am going to discuss energy diagram of SN1 and SN2 reaction. In my first video, I have discussed that nucleophilic substitution reaction are two types, SN1 and SN2. For SN1 reaction, formation of stable carbocation is a crucial factor. So that's why here we have taken tertiary butyl chloride, which can form 3-degree carbocation, which is very stable. And the first step is the slowest step, and it is called rate determining step or RD step. Now in the second step, the nucleophile will attack to the carbocation. Here nucleophile is methanol and nucleophilic center is oxygen. So this is the first step. Then we get this compound. Since here oxygen is positively charged, so in the final step the deprotonation will take place and we'll be getting this product. So this is product is ether. So we started from the tertiary butyl chloride and we are getting ether. So stability of carbocation is a crucial factor of SN1 reaction, and that's why 3-degree carbocation proceeds via SN1 reaction, but the secondary and the primary carbocation proceeds via SN2 reaction. Let's explain the energy diagram of SN1 reaction. For SN1 reaction, formation of stable carbocation is the slowest step and it is called rate determining step. Now in the energy diagram, this is the energy level for the nucleophile and the substrate. So here nucleophile is methanol and substrate is tertiary butyl chloride. Now here we have to supply the amount of energy which is needed to break this carbon-chlorine bond. So this is energy which is needed to break this carbon-chlorine bond, and it is called activation energy of this reaction. So this is the first activation energy of the reaction which breaks carbon-chlorine bond, and this is called transition state. So transition state means where leaving group is slowly breaking the bond. Means leaving group is slowly leaving the carbon. So this one we can show it by a dotted line. So this is called transition state. So here activation energy is needed to reach the transition state. So once it reaches to the transition state, it forms a stable carbocation. So this on the stable carbocation. Now it needs another activation energy where the nucleophile will come and make a bond with the carbocation. So this is the transition state where nucleophile is slowly approaching to the carbocation. That's why it has been shown as a dotted line. Once this dotted line forms, means once the transition state forms, then we get the product. The product is R with nucleophile, means alkyl group with the nucleophile. So this is coming from the nucleophile and this is from the alkyl group, and the leaving group will be Cl minus. Now from this energy diagram, here you can see there are two activation energies needed. The first activation energy needed to form the stable carbocation, which is more, and the second activation energy is needed to make a bond with the nucleophile, which is less. So that's why the second step is the first step, means it happens quickly, and the first step is the slowest step because it needs more energy, it will take more time. And the product energy level is less than the energy level of the starting metal because product is, it's an exothermic reaction and product is more stable than the starting metal. That's why energy level of products are less than the energy level of starting materials. Let's explain the energy diagram of SN2 reaction. For SN2 reaction, we need a primary or secondary carbocation. That's why here we have taken ethyl chloride and methanol as a nucleophile. Now carbon-chlorine bond will break and nucleophile will attack at the same time. So SN2 reaction is a concerted process where leaving group leaves and nucleophile attacks happen at the same time. So this is the way the transition state has been shown, that here leaving group is leaving, that's why it's a dotted line, and nucleophile is approaching, starting to make a new bond, so it's a dotted line. So from the energy diagram we can see this energy level corresponds to substrate and the nucleophile. Then we have to supply the energy which can break this carbon-chlorine bond, and it will reach to the transition state where carbon-chlorine bond is started to break and nucleophile is approaching to the carbocation. So this is called transition state. This one is transition state. So once it reaches to the transition state, leaving group leaves completely and carbocation forms a new bond with the nucleophile methanol. So this is the energy level of new product and the leaving group. So here leaving group is Cl-. So now we can make out the difference between SN1 and SN2 reaction. SN1 reaction is a two-step reaction and the SN2 reaction is a one-step reaction. So where the leaving group leaves and nucleophile attacks at the same step. And this is the first, the first step is the slowest step. That means it is the RD step. And this is the activation energy is needed to reach to the transition state, then only product will form. I hope this video will be helpful for your study. So if you like this video, share your feedback and share it with your friends. Subscribe my channel Chemistry Affinity, and if you have any queries related to chemistry, you can send me a mail to chemistry.affinity@gmail.com. Thank you for watching it.